So good evening, everyone. Welcome to the fifth day of a six-day faculty development program on advanced artificial intelligence and machine learning techniques for medical imaging applications. We are delighted to have with us our resource person, Mr. Abhilash Raghunathan, co-founder and CTO, Dr. Assist AI. He is a technology leader and innovator with over 16 years of experience applying artificial intelligence to biomedical research and healthcare innovation. As co-founder and CTO of Dr. Assist AI, he leads pioneering projects in oncology and neuroscience, integrating AI, medical imaging, and multi-omics analysis to tackle some of the most complex challenges in the modern medicine. His expertise spans machine learning, computational biology, and strategic product development, with notable achievements in cancer detection, single-cell omics research, and neuro disorder analysis. His work bridges advanced data science with clinical application, driving forward the future of personalized medicine. A passionate advocate for interdisciplinary collaboration, he regularly engages with global researchers, clinicians, and technologists to push the boundaries of AI in healthcare. We are truly fortunate to have him here. His expertise will enlighten us and open new perspectives on the progress in deep learning approaches for medical imaging applications. With great pleasure, let us welcome Mr. Abhilash Raghunathan to begin today's session. Sir, please.
Thank you, all of you. Thank you for giving me an opportunity to, take a lecture on the image processing kind of stuff. Let me share the screen first of all. Hope you can see my screen.
Yes, sir.
Yes, sir.
Yeah, the thing is today we are going to discuss about the progress of deep learning for medical imaging, where we cover the stuff like agentic image processing and image assisted surgery kind of stuff. So, as an introduction, why medical imaging is needed. So, these are different areas where the image processing is a must. That should be image is a data that should be processed for a must. It can be used for diagnostic kind of stuff, prognosis kind of stuff, for surgery planning or non-invasive insights. Like if you want for a diagnostic particular disease, like maybe lung cancer, lung nodules, tumor, or MRI, something like that, or fracture or CT or X-ray, they can be used for diagnostic purpose. The prognosis, some sort of images should be analyzed to understand how the disease progress. Like if so, in case of cancer lesions or maybe something like that, we should understand how the disease will progress. And after that, we should understand if you want to know the post-treatment, recovery plans or maybe protocols that should be followed. So it is used for that prognosis kind of stuff. And for user surgery, we can use image processing kind of stuff to assist you surgeons and planning complexity of the procedures, brain surgery, cardiac bypassing, and everything like that. And it's in case of invasive insights, like we can have a window inside the body without invasive methods, like reduce the risk and improve the patient comfort. So these are the basic, need of the image processing in the medical segment. So if you want to go understand the role of deep learning in transforming images, like it can be used for automation, precision, give the automation, precision, speed, personalized therapy, and for the innovations like AR, VR kind of stuff that can be used. In case of automation, we can understand diabetic retinopathy, detect abnormality from the diabetic retinopathy, precision, pinpoint details of invisible human eyes, and minimize diagnostic errors. So these are the area that AI can use for that. So if you analyze that evaluation of medical imaging, it's the same as the data science, like traditional AI kind of stuffs are there, and after that the ML kind of stuffs come into market, and deep learning and agentic platforms. So what's the traditional image processing like? It's a mathematical algorithm with help to detect the edges, filter thresholds. So what are the area that can be
Sorry for the interruption, sir.
Yeah.
Sir, 1 second. Some noise is coming in from your background or some other participants. Some sound is coming.
One second.
Yeah, it's good when you are speak with
Yeah,
without those kind of artifacts.
yeah, yeah, yeah. Sure, sure. Uh, it's okay now, right? Hello, hello.
Yeah, yeah, it's better.
Yeah. So what happens, like in the traditional image
Yeah,
processing, like yeah, traditional image processing system, like the rule based system, where mathematical algorithms like edge detection, filtering, threshold values will be analyzed. It's worked well in the basic enhancing, like noise reduction, segmentation kind of stuff, and it can be adapted to that area of image processing. And if you go for machine learning kind of stuff, it is using SVMs, like a support vector machine or random forest, to learn the data. Like it helps to understand the data patterns out of that. So it is used for tumor classification, listens detection, organ recognition kind of stuff. Like and it still require manual features extraction, like texture, shape, and intensity. When the deep learning kind of stuff come into market, like after 2012, what happens, like the evolution of CNN, RNN, GAN type of deep learning technology comes into market. So it is capable to transform automatically. The features can be extracted from the images. So the electronic kind of stuff come into market, where like it has a supervised model, where a deep learning model with this can help to understand the diagnostic tasks, like skin cancer detection kind of stuff is coming to market. Now it's a new era, like where after 2024 25, like the agentic AI kind of stuff come to market, where it actually plan the reason and adapt according to the situation. Like if you want that radiologist to understand the condition of the patient from the image processing kind of stuff, now agentic AI kind of stuff is emerging in such a way, like it will combine the different scans, EHR or genetic data, and it will give the insight from all this things, and give a personalized insight from the using agentic AI technology. So this is how the technology emerged from the initial state to now. So the core challenges of medical imaging is something like this. It's a medical image. Most of the medical images, like CT, MRI, high dimensional images, but like images like it can be higher resolution of voxels and pixels may be there. It may be in 3D or 4D or computer devices, something like that. And the problem of the most of the device, like images are something like that. Noise and artifacts will be higher, so some sort of blur may be there, low cost contrast may be there. So these are the challenges that when we consider when we process images. And the lack of label scarcity is there. We used to process these type of data. The label data should be there, like label data like a radiologist or pathologist should sit together with the images, and label the abnormality in that images, and then only we can train the model with that data. So it is costly mechanism for that. So the scarcity of label data is the first problem when we go for the image processing in the medical kind of stuff. So moreover, the need interpretability, like a doctor need to understand why model is flagged in some region, or maybe like there's no clear explanation. What like if you train the model with the data that is or maybe label data also, in some cases, like the explainability is not that much established till now. So when we go for the details about the medical architecture, like some of the major architecture, let me explain that. CNN may be used, where like this is considered the backbone of medical imaging technology. It automatically extract the features, adjust textures and patterns from the images, and it is used for task of application like classification, detection, and segmentation. When you go for classification, it can be used for detecting pneumonia kind of stuff in the chest X-ray, skin cancer in dermoscopy, in detection, and like nodule fractures and tumors. Like it will identify that nodules in the X-rays or CT scan, and fractures and tumors. Segmentation is like in case of segmented tumor or organ part as a wall. So that all these tasks can be achieved using convolutional neural network. So this is the architecture of convolutional neural network. If you input an image, the convolutional layer will be there, multiple layers of convolutional layer will be there, and pooling layer will be there, and the flattened layer will be there. After that, the output will be categorized, like maybe whether it is like we can understand some sort of lung nodules out of that, maybe pneumonia in the chest cancer, something like that kind of stuff can be analyzed from the convolutional neural network. when you go for RNN kind of stuff, the much more accuracy, like accuracy kind of stuff, where when achieved using temporal sequential dependencies. Because that is like when a data, like the previous layer is dependent on, like previous data is also dependent on the, like decision of this layer will depend on the previous layer, and we use RNN kind of stuff, where like sequential data or dependence factors of the previous condition may be that, like when you consider cardiac, MRI, ultrasound, like it's a video kind of stuff is there. So like what transformation whether that happen from the this layer to this layer will be considered in the recurring neural network layer. So self-attention mechanism is used, and vision transformers are used in this level. So what is the application of this one is that tracking disease progression across time, like because like if you consider about this CT scan MRI like that, we can compare the pattern with the previous CT to now, and like that tracking disease progression can be analyzed using this kind of stuff. And moreover, the video images like endoscopy or maybe echocardiography should be processed using the RNN kind of stuff. When you go for like a GANs network, GANs network will help to generate discriminate produce realistic synthetic images, where like it is considered as like a generative kind of stuff, where like it help to produce the synthetic data. It's first and foremost output that we can deliver using GAN networks is the synthetic data. Second one is like creating medical image overcome label scarcity, like because like the synthetic images can be used for the training in the later stage also. Along with that, enhancing the MRI resolution, like if you get MRI images from adverse network, we can enhance the resolution of image, filling the missing data that is helped there. Cross modal like can be converted to MRI can be, or maybe PET to CT conversion can be done, or maybe using the overlapping methods can be used in that area. And some sort of diffusion models are as well next generation technology than a
No, maybe his connection lost. Uh, Participants or for the inconvenience. Yeah, sometimes you lost.
Hello?
Hello. Yeah, we can hear you.
Hello? Can I continue? Hello?
Yes, 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 yes.
One second. Can we share the screen once again?
Yeah,
Yeah. You can see my screen, right?
yes, yes,
Hello?
yes. You
Yeah.
can continue.
So we start with the agentic kind of stuff where like agentic technology is something like system capable of reasoning, planning, and acting autonomously. There's a difference between the normal system to this one is like it will reason themselves and plan the activity, and it automatically decide the decisions. Some cases like patient data is collected, scans, which scan should be selected for particular case will be done, and pre-processing done will be done automatically and analyze the structured report generation. Example of this kind of stuff is like if an give for MRI scans, the agent can choose the best sequence data and parameters. Like so, no need for giving the best sequence data or like the parameters of like it will choose automatically depending on the patient condition. Like if want to understand the stroke, they will go and understand and see
Uh, sir,
which sequence
your
should be
voice is
analyzed or
breaking.
maybe
Please check your
more
connection.
they go and understand which sequence reduce radiologist workload and ensure static protocol across the patients. And it will help decision support during the image analysis, provide real in-time guidelines while radiologists will get areas like lung nodules, tumor. Hello, can you hear me?
Yeah, sometimes, but your voice is breaking.
One second. Hello, hello.
Yes, 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 sir.
It's better now.
Yeah, better. Please share your screen.
Okay, fine.
And the feedback from the faculties is that you are you are please reduce the space of your lecture sometimes.
Fine. So, we are discussing about the agentic kind of stuff that can be the relevance of agentic AI kind of stuff in the image processing kind of stuff. So, what we can like, so we discuss about what's the automatically image workflow. Automatic image workflow is the once again. Hello, hello.
Yes, yes, yes,
Once again.
yes, sir. We can hear you.
Yeah, fine. So, in case of agentic technology, like it automate the image workflows, like it will pick the data, it will help from the data selection and pre-processing, analyzing the structure report generation kind of stuff, like analyzing the data whichever it is needed, and the structure report will image directly. So if for example, if an MRI agent can choose the best, can send a parameter depending on the patient condition. Like if you want to know for the stroke or tumor protocols, like it will go and seek the best image that we process, and it will give the structured document out of that. So it is automating that kind of stuff and reducing the workload of the radiologist. Second one is active decisions for doing image analysis. We can be doing using agentic kind of stuff, where provide the real-time guidelines with radiologists while viewing the images. Like if a radiologist want to, no need for radiologists to go for every sequence. Like in case of but the CT scan kind of stuff, like maybe at least maybe 50 images should be processed parallelly. So it will help the highlights the area of concerns. Maybe in this image, the lung nodules, maybe there is a 3-dimensional image is there. So no need for radiologists to go one by one. It will what they indicate like this length can be found in the 5th image or maybe 66th image. So he can go and like lung nodules, tumor, or anything and stuff like that. It's actively decision support will be help using this technology. Adaptive imaging pipeline maybe like images something like that. AI dynamically modulate radiation dose and minimize exposure to while preserving image quality. So if you want for radiotherapy or something like that, we will optimize that kind of stuff using agent technology. So it improves clinical decision making, reduce cognitive load of burden of the radiologist, support personalized medicine, and facilitate collaborative care and real-time monitoring alerts. So these are the advantage of using agentic technology in the radiology. So agentic case example radiology, pathology, are basic example, and cardiology are the basic example of using agentic kind of stuff. In case of radiology, agent can review incoming CT, MRI scans in the real time, identify critical findings like stroke, hermography, actually, and something like that, and automatically prioritize cases to your workflow. Because like the first screening will be done using that towards the technology itself. So no need for like a doctor take the normal cases, like abnormal cases will be prioritized by the system directly. So it will help in that kind of stuff, reduces reporting delays and life-threatening conditions. So it will be enable faster interventions. Stroke patient get flagged and brought into top of the queue with minimum minutes of scan completion. So like normal cases can be processed using technology. In case of pathology also, the digital pathology slides are often the size of the digital pathology is huge. So it is not easy for a manual review or it will be time consuming. Agent kind of stuff help to adapt scanning, focus only in the region of diagnostic value. Like it will mark the area of the which are the cancer cell may be there, which are the how the big it is, the size of the images will be can be marked using the technology. And so dynamically adjust the zoom level and resolution, low magnification, and for the screening, high magnitude for a suspicious area. So to a tumor, maybe a tumor margin can be marked. It is significantly speed up the cancer diagnostic while ensuring no relevant areas will be missed. In case of cardiology, echocardiography requires skillful probe placing in the accurate and for the accurate imaging. So agent A kind of stuff can be used for guidelines technical, less experienced operator to use go for the cardiography. So the new technology that is emerging in the marketplace is image assistant surgery, like you know about robotic surgery kind of stuff. So the same using the robotic surgery also. When if you want to go for surgery, the CT scan will be analyzed and the area of interest will be marked by a technologist or maybe a surgeon, and as per that the robotic will I would say emulate surgery on behalf of him. So real-time surgical guidelines will be we can be using deep learning. Deep learning models process interoperably images like MRI, CT, ultrasound, like because like we the 3D view of the CT, MRI from different images, and can be merged, like CT and MRI can be merged and 3D images can be produced. Helps the surgeon to visualize critical stuff or vessels, tumor, nerves, and everything like that. So see, using the guidelines, resume navigation, reduce the damages, example tumor margin can be understand during brain. And we can incorporate AR glasses and during surgery. It superimposes the CT and MRI in front of the glass, so patient body and while doing surgery. So it will give you a 3D view of the organs or something like that. Enable pre-surgical rehearsal also. If you before surgery itself, wear glasses can emulate the same condition of the patient before surgery, so we can reduce the complication of the surgery using this kind of structure. surgeons see critical anatomy of the overlaid what's a tumor, vascular maps, or maybe something like that, improve accuracy in that way. And robotic assisted surgery, in case of operation, enhance instrumental precision and stability, provide tremor reduction or and fine motor control, and can analyze interpretive data and suggest next steps that should be done using robotic surgery. System can interpolate decision making. Agent can doesn't just assist, it will reason and adapt. Alert when blood loss is exceeds the threshold level, and recommend the alternative surgical routines. If some in case of surgery itself, if some sort of I would say abnormal patterns happen, maybe higher blood flow happen or something like that. In the pre and post operative surgery can be adjusted using agentic kind of stuff in the real world scenario. So there's a different layers of deep learning technology can use, like as you know, like the supervised learning is like unsupervised learning is, semi-supervised learning is like each of them have that there are advantages and use cases is there. Hello.
Yes, sir.
Hello.
It's audible.
Yeah. The most widely used mechanism for image was like your large should be there. Radiologist should annotate the scans and give the as input. So key application diagnostic classification, detect disease, pneumonia, and from chest X-ray and tumor and MRI. And it is used for segmentation, kind of identify organs, tumor boundaries, and pixels can be done using supervised learning. And prognosis can be identified using supervised learning. And unsupervised learning can be used for like work on unlabeled data. No ground truth will or labels will be given as input. So it can be used for clustering, anomaly detection, dimensional reduction kind of stuff. Is the application of the unsupervised learning kind of stuff. Is the grouping the patient with the similar images, because like the same kind of tumor is there already there in kind of stuff. Subtypes of brain or lesions can be identified using clustering methodology. And anomaly detection is a kind of stuff like rare tumor or maybe some sort of normal anatomy can be understood from using anomaly detection. Dimensional reduction is compressing images features for better visualization and analysis. So like if you want to reproduce the same images like into higher resolution, something like that, we can use the dimensional reduction and we can reproduce the same images with higher clarity using unsupervised kind of language. And most of the time they use semi-supervised kind of stuff. Uses a mix of label that should be arranged, self-supervised learning data will be used, and training. Few expert label scans can be inputted and leverage large archives of hospital images. Improve generalized will be done using this one. Then the other kind of stuff are like reinforced learning and federated learning. Reinforced learning agent can learn by trials and rewards mechanism, where like it will adapt to the situation as per the input of the patient, the condition, like optimize MRI scan parameters, faster high quality imaging, radiotherapy planning can be done, and surgical robots can use the reinforcement kind of stuff with the reward making, real time navigation, how it should be navigated, tool placement mechanism with feedback loops. Federated learning kind of stuff can be used when collaborating training across multiple hospitals without sharing the raw data. So each hospital trains locally developed model. It can be transferred from one trained model to another one using federating kind of stuff. The basic things that we consider should be considered while implementing some model in the hospital is something like clinical validation needed, safety consideration should be taken care as an AI tool. It should undergo if any models is developed on the any scenario in the hospital should be undergo strict regulations like FDA kind of stuffs, and in Europe it is like a CE marking should be there. If it is diagnostic kind of stuff, the CE marking is a must for European standards. Other standards like a CDSCO in case of Japan,
For a
PDM,
second,
PMDA, and yeah.
sir, the participants are requesting that you should go a bit slower so that it can help them to follow better.
Okay, fine.
Okay, thank you, sir. Thank you.
Yeah. For any models that they trained on any scenario should be implemented in hospital, you should undergo safety considerations. A lot of safety parameters are there in different region, depends on different region, different parameters are there. In case of US, like FDA is the gold standard, and is Europe is the CE marker is the gold standard. and India CDSSO, because like it should be validated extensively in that region specific conditions. Like if you go for the X-ray itself, like in the chest X-ray, if we can understand the abnormality in some region may not be applied as abnormality in another region. So it should be validated. The validation should be done. That's the key challenges of the system. And the data sets or benchmark and training is like in case of chest X-ray, NIH chest X-ray, 40 large scale chest X-ray radio data sets is like it's a huge volume of data, resolution higher, and for the disease classification kind of stuff, brain tumor segmentation, the data sets and benchmark is a it's a limitation. Standard interoperability procedure should be followed, like DICOM. Like most of the images are not like PNG or JPG format. This is a digital image and communication and medication format. So standard for storing like some sort of device like PACS or software like PACS should be there. The PACS is something like that, picture archive and communication system, that is a global standard for saving the image data in any hospital. So the DICOM as the digital image communication system is a format that should be saved. So what is like this standard and for interoperability should be there. And like for transferring one data from one hospital to another, they should follow the standards of fast FHR protocol should be there. This is fast healthcare interoperability resources. So one hospital need to transfer, like in case of most image processing kind of stuff, it is already like the FHR standard is already satisfied, because like the DICOM is a common platform, common image format that is used by most of the hospital, and the PACS is the system that is used for storing that one. So FHR protocol is almost satisfied, but like other standards should be followed. And challenges is like data privacy and biasing may be there, like data privacy like HIPAA compliance should be there, and we already discovered that. And medical image data often contains sensitive patient information. So all the patient details like name, address, or the patient information should be biased before taking it for any transfer or maybe learning kind of stuff, because like if you go for training kind of stuff, no need for the patient information, not needed at all. So data privacy should be considered, and this is a challenge for the getting the data. Sharing pooling data across hospitals is difficult due to privacy concern of the different hospital, leading to fragmented data sets. Model explainability, like the basic problem of, because like in case of generative AI kind of stuff is there. If it is LLM model, like large language model, it is producing what's the data we can validate, like we can validate from the by reading the data. But like in case of image processing kind of stuff, the only experts can analyze that. So moreover things like if it is segmented at some area or tumor, something like that, the explainability is a much more lagging in the image processing kind of stuff. Deep learning models like CNN or transformers or GAN network is a completely black box till now. That's prevailing in the market. Real world deployment in hospital, many AI models show excellent performance in the research and settings, but like in the real scenario, it's like still lagging. Like because most of the hospital didn't have like PAC system or EHR EHR integrated. So these are the challenges included for the data transfer. And future direction is the multimodal learning kind of stuff, where like multimodal is like the patient what's the disease is complex, what's a multi-dimensional problem, where we get a lot of information from X-ray, some information from MRI, some information from CT, and like clinical data is the other factors like lab report, vitals, other inputs that. So for understanding the patient condition, the combination of all these considered conditions, like not like image processing only, all these conditions should be processed. So the multimodal architecture are coming to market, like by most of the newly developed model, has the capacity to understand images, pathology, like images like radiology images like X-ray, CT, MRI, along with pathology images, and data like EHR or genomic profile may be considered as data processing tools. So the multimodal should be capable to analyze all the multidimensional problems and get an insight out there. This fusion allow AI generated holistic patient view, linking tumor images with gene mutation and lab results. Example, breast cancer diagnostic model using mammography, biopsy are the multidimensional problem that can be solved using technology. Agentic surgery assistant is other what say other area that's like image processing can be applied. It is used for agentic like because moving beyond static image models, like it can reconstruct surgical navigation, guideline instruction, 3D reconstruction. agent adjust intraoperative challenges like how to navigate error prediction, detects anomalies, bleeding zones before surgery. Surgeons act because like in the from the images we can process the data, and agent can predict like these are the safe zone that can be operated, because like in case of veins or something like that, some veins has got when some veins are cut, the bleeding may be higher, so it can predict that kind of stuff, and like get the doctor go for the safe zone, not into unsafe zones. So these are the like through glasses and all, like if a doctor incorporate glasses while using the surgery, it can be notified using that kind of stuff. Personalized or precision images can be done image protocols like based on age, anomaly, and like anatomy and disease risk can be analyzed, and the personalized precision can be delivered to the patient. The predictive imaging, like a anticipate disease progression, like because like if a tumor is in this size, like how the disease will progress in the after maybe 6 months, like so the doctor can explain to the surgeon, no, maybe a patient like something uh, like whether we should go for the what are the where we should do intervention should happen, whether it's after 6 months, like how the much size will increase, something like that. So patient so personalized precision can be delivered. So as a conclusion, what we can tell, like deep learning model revolutionary medical imaging segment, it can help the doctors or clinicians to detect, segment, classify kind of stuff. Now new kind of stuff like agentic kind of stuff can come into market, which is helping analyzing the let's say abnormality automatically, like maybe autonomously. So what happens, like it help do surgical assessment and other kind of stuff beyond passive prediction, it towards active reasoning and decision making system, it can be incorporated. So these are the surgical assistant tool is an what's a promising field for that we can look forward while using what's a image processing system. But it should be a balance of technology and ethic and clinical adoption should be there, because like doctors are the what's say final decision maker while concerning case of patient safety and data privacy kind of stuff. So these are the things that we should consider while using the technology into the clinical practice. Thank you. Hello. Hello.
Yes, sir. Um, Sir, lecture or it's continuing or what?
Uh, like how it works, like
Okay.
hello.
Yeah, yeah. Tell me.
uh,
So we are planning like a 1.5 hour. So did you finish? Okay. Then we can switch it to like discussions for half an hour. It's possible for you, sir?
yeah, yeah, the thing is like I'll go for a live explanation how an image is processing the live way. So
Okay.
let me share the screen once again. I'll give you a live demo of the tool. Can you see my screen? Hello.
Yeah, it started the screen sharing, but still not visible for us.
Can you, um, can you see once again? Let me once again.
Yeah, try one more time.
Yeah, see my screen. Hello.
Sir.
Hello.
Mm, mm.
Let me
screen is not visible, but you try to. Now, okay.
Hello.
Hello,
Yeah.
sir.
Can you see my screen?
Yeah, now it's showing. No, this time the FDP page is coming. I think your screen.
Can you see my screen?
Yeah. Now it's
Yeah.
coming. Like, thank
Fine. Fine.
you.
Fine. Fine. This is how an clinical support system will work, where like today's appointment will be there. Like he can click on the nurse or maybe primary center will click on something like that, and here we can upload any sort of X-ray, CT scan kind of stuff, and describe the region of interest, maybe chest or anything like that, and what's the problem will be marked, and focused area of image will be marked, and if you upload some sort of image processing kind of stuff still is there. So here we can upload X-ray or maybe any kind of stuff will be uploaded. So in the background, what happens like it is calling like the AI model which is deployed in the server. It will process all the informations in the background, and it will mark the underline the conditions of the patient, like in agentic kind of stuff. It will like take little bit of time because it's processing the image in the pixel by pixel, but like
Uh, uh, Sir, this tool developed by your company.
yeah,
Okay,
yeah.
okay.
So it is
And
processed and like it's like hello,
also that will be helpful.
hello.
Yeah,
So it process the image, and we will get a return at like findings is there, like upper lobe length, some cause of mass or tumor is there, so large opacity is there. So these are the information that we get from that image. You got it right?
yeah,
Hello.
yeah. The report
Yeah.
is visible. Yeah,
So what happens like when a doctor is consulting the patient, that report will be shown, like because like if it is uploaded in the background, so it is processed, and you can see that left upper lobe is there. This is the primary diagnostic that is and it is analyzed, and we will process the confidence score about this condition, where like there is a large irregular capacity of left upper lobe will be there. So it will go through the images, and like it process the data and show in front of the doctor, so he can do his consultation. While doing his consultation, all the what's this is a multimodal architecture, where like we'll consider lab vitals will be there, lab report will be there, and process the image report also there. So based upon that condition, he can do his consultation. Got me? So it's a classic example where like the image processing will be incorporated directly to what's say the clinical practice. Got it?
yeah. That means you are this doctor assist those device or those tools. Have you deployed in any hospitals or any imaging centers, etc.?
Yeah. We deployed in the leading hospitals in Kerala, where like they are using for the what's say it will be incorporated directly to the PAC system. Like PAC system is the picture archive system that we are already discussed about that. So in the it will take the data from the PAC system and process that data in the pipeline, like because like we have different what's say image cleaning and that kind of mechanisms are there. After that, we that process data will be shown in the front of the doctor. So while he's doing the consultation, that the only the abstract of the X-ray or CT scan should be processed and shown, because like as a normal case, what happens like the radiologist will be the person who process this information. Not me. Here, what was like that part can be what's emulated or maybe replicated using a software like a technology software like that, as we already discussed. So it will reduce the time duration for the consultation. Like in case of stroke and all, we should understand the stroke in different perspective, like whether it's a bleeding happen or maybe it's not like any no injury only. For me, it's the category of the modality that is used for the stroke is different. If it is bleeding is happening, there's some other modality to use. If it is injury only, like actually some other modality to use. So it will reduce the time duration for the that sort of analysis.
So that means this your tool is helpful for the radiologist, or you are going to show these results to the specialist.
Yeah,
Like
yeah. The most of the image processing tools are used for radiologist kind of stuff. Most of the image processing can be used for radiologist kind of stuff, but as like this is the clinical and also clinicians, and also that's what I want to explain to you. Clinician and is like something like that, because like the radiologist will go through the images of the X-ray, CT scan, MRI, and underline the abnormalities of the images. Abnormalities maybe but if you think in the direction of clinician, there's a no there's like abnormality in the normality also. Got me? Because like if some sort of what's say muscle strength should be considered, other condition can consider. So all this interpretation can be done using an when same image processing kind of stuff in the what's say X-rays or CT scan. Got me? Before going
so,
for surgery, yeah. So before
yeah.
going for surgery planning
So
kind of
your
stuff.
tool, like, yeah.
In case of surgery planning kind of stuff, it can be used for what say planning the surgery in the like what are the complications that happening in the that may happen in using surgery, because like these are the veins that should be considered, these are the organs that you should consider, that can be emulated in the previous and before that, and after that it can be planned according to that condition. And after that, what was like we can do one thing, uh, uh, we can optimize the total procedure using the technology tools. So it can be, and it can be used in the radiologist along as well as the clinician also, because that's the advantage of like this previous condition is something like that. The X-ray, CT scan pathologies are should be kept in the radiology end only. Now it can be used for the both end.
Okay, so what are the modalities? It's very accurate in by using your means like your tools, like suppose X-ray, CT, MRI, PET, CT, etc. So ultrasound as well. So
Hmm.
which one is more reliable or more suitable with your tools, or it is performing well with all kind of modalities? Which one? What is your response
Yeah,
regarding that?
the thing is like the most of the what's the training happen from the like training data is available in the market nowadays, because like training data sets is available in open source models, like the company like Nvidia had done an extensive training with the label data. We can take the data and train the model with the like there's a kind of stuff called fine tuning. Not like we are not supposed to do the total training of the new model that is available in the market. Like we can do the fine tuning kind of stuff, because like the fine tuning is something like that. If a model is capable to understand the tumor level, we can use the same model to tune it to understand the what's say organs also. Got me? The segmentation can be done like if you understand the segment of the organ, we can use the same for the tumor also. So that's like vice versa can be used. Got me? So what happens like the fine tuning kind of stuff can be like, because these models are already trained, extensively trained on by the Nvidia, Google, or maybe Amazon. We can take that model, that's an open source available models, and like we can fine tune with the data available in the Kerala situation or maybe Indian situation. Got me? Like if the data size is less, like maybe 1,000 data is we have only 1,000 data which is labeled enough. We are not supposed to train a model with the 1,000 data, because like it will not give you any accuracy at all. So what we used to do is like we'll take the model that is already developed in the what's say abroad, maybe by Nvidia or Google or Amazon, some kind of service, like we what's say fine tune the model with the data that is existing in the Indian market. So now what happens like like to respond to your question, something like that, we are capable to understand the X-ray, CT scan, MRI, PET scan also. Ultrasound is still in the development stage.
Okay. So that means from any body parts, the segmentation or quantitative analysis or tissues, it's like a tumor detection, everything is possible with your tool.
Yeah.
Without like any modality, they give good results. Okay. So with that, one more thing is like how the validation occurs. Also, how validate your system? Also, who validated your systems, and what is? Can you explain a little bit about those things?
Yeah, sure. The thing is like this kind of what's say, if you want to go for a diagnostic kind of stuff, so that should be validated what's say, extensively on the by the different therapists, like in the clinicians, like radiologists and pathologists, all the kind of stuff are there. If you are what's say in the diagnostic kind of stuff, but like in case of what's say clinical, and like we are helping the clinical decision support system only. So the radiologist data will be there. Along with that, we are what is helping like we are what's say marking the segmenting the area of interest of the particular clinician. So like it is also it is also undergone the validation by different hospitals, like we are incubated in the leading eight medical colleges in Kerala itself. Got me. So we are what's the using like with the expertise of the different doctors in that hospital, along with the other hospitals in India. We are validating this kind of stuff. So it will be coming to market like for the end user kind of stuff. End user kind of like even doctors end user in that scenario. Got me. Like if it will come in the later stage only. Like the image processing is like no stage now only. Some companies like QRA had done an extensive study on the radiology image only. Radiology like X-ray. Just what happens like some the gold standards are there. FDA approved should be there for taken to directly into medical practice. There's some there's no much more than like 15 companies are there, like who undergone like even let's say pneumonia detection kind of stuff. Like some FDA approved are there. Most of them are like in the clinical validation stage. We are also in the clinical validation stage.
Okay, okay, got it, got it. So, yeah, your tool. We see what I understood is your tool is now successfully going with the helping the radiologist, and what you are done is you selected the checkpoints or pre-trained models, and you done some training or additional modification with the Indian data or Kerala data or in hospitals data, and your tool is now it's live in Kerala, means like hospitals and medical colleges, right?
Yeah. The thing is like if a radiologist want to process and data, like it's like it should undergo like it will take another 3 hours time for a radiologist to go for each and every slide to understand the pattern from CT scan itself. Like it's like a most of these cases are life saying kind of stuff. But like if and the tool that we are delivering to them will process all the informations and like show in front of the radiologists, like these are the but say most probable three slides should be you should consider. Got me. Most probable 3 or 4 slides you should consider. It itself reduce the time duration from 3 hours to half an hour. Got me. So doctor can like and radiologist can check the if the CT scan is there, so like 70 slides maybe there. Out of that, he should check at least 5 of them, because like we analyze the data and find abnormality on the 5 of them. Okay, if the abnormality is there, and from the CT scan also we can give different perspective. Like because like if you go for the what's say robotic surgery, or maybe on ortho surgery kind of stuff, we should have a different angle, like because like how the bone transplantation, or maybe joint transplantation happening. The X-ray will give, or maybe CT scan give you one direction of that. Through system we can give the multi-dimensional, okay, how it fit to the bones, or maybe joints, or kind of stuff. So much more accuracy or precision can be given using the technology. But like I can't tell you like it's like 100%, but the rest of things the doctor can adjust it out. Doctor can it's because like we are giving this tool to doctor directly, so doctor would know like how it works. So but it will be a decent angle, or maybe decent direction how to predict the things that are going to happen.
Yeah, that means it's helpful for the simply we can say it's helpful for the clinicians or radiologists. So,
Yeah,
sir, I can ask like you discussed like uh, you developed the systems or the some AI tools, and based on that, this process is going on. So, can you tell me about something related to that, like what kind of AI architecture you are using and or used for the development of all the system, or what are the basic structure you used, and what are the modification you used, and what are the challenges you faced during the development of these models and training and testing, etc. Can you share those things? It will be good for us.
hello.
Hello.
Yeah,
Hello.
can you repeat the question once again?
Yeah, you develop the AI models or train the models, etc. So can you explain a little bit more about what kind of algorithms, or what are the algorithms you used for this, and what are the challenges you faced when you are playing with these kind of AI techniques? So what are the specific AI technologies or techniques you used for developing these tools?
Yeah, if you want to try and understand a small what's a task we had done, something like that. If you want to increase the resolution of one image, or like if you want to like increase the resolution of image, like if you want to recreate one X-ray model, like maybe because of some let's say it has got like different layers is there. Along with that, like if you want to enlarge into some extent, we can use the unit architecture there. Unit is like a, we can use for one layer of the unit can be used for compressing the hello
Yes,
one layer.
sir. Yes, sir.
Yeah,
Your voice.
yeah, one layer can be used for compressing, another layer can be used for decompressing that data. So that's the same steps can be used for what's say compressing one layer and decompressing that one. So zipping and unzipping will happen, like so it will increase the resolution of the particular area of interest. Got me? So maybe in case of tumor or maybe abnormality in the one some organs or something like that, we are using unit kind of stuff. And CNN models are used for what's the segmenting kind of stuffs, where like we can segment the particular region like tumor, maybe any abnormal area that or maybe area of interest may be marked. So what is like even we can use the what's like in case of surgery kind of modules, where like they will mark before surgery itself, they will mark the area of interest. And after that, because like and like after surgery also, like in between surgery also, they can check whether that tumor is completely removed or not. That can be checked using the technology, where like they can use the glass or kind of stuff, where like the area of interest will be marked in the glass, so he can recheck whether the tumor is totally removed or not.
Okay. Okay. One question from Professor Vivek in the chat box. Sir, once the platform is done and calculate the results, how it will be updated for new coming algorithms, or time to time it updates itself?
uh, the thing is like the algorithm will not update itself. What means like the algorithm that we use will be unique all the time, because like if you develop an algorithm, a model kind of stuff, it will be there for an extent of maybe it will not change at all. Like we can fine tune to the new data that is available in the market. Got me? Like if you are taking the Kerala situation, like if you get some sort of South Kerala or North Kerala data is there, like if you train the North Kerala data only, what is like after that we got some more data that can be used for training. It can be used for fine tuning the last final layers of the system, where like uh, but there also we can use something like that. The weight of the model can be changed depending on the condition, because if you want to know, like because after training the model we can understand, okay fine, these are the area that is given the what's say higher weightage. So we can develop a model, and the weight can be uh, saved somewhere. And if the new model is should be deployed, we can have the another base because based on the condition out of maybe our preferences. Got me? If you apply the new ways to the existing model, it will be like if you, for example, if you develop a model for the South Kerala, the weight will be saved in somewhere, and like if you develop the same model for the North Kerala, what is like another weight will be developed. So what is like as per the weight, that condition of the algorithm will different. Got me? And the what's the precision or prediction, that's kind of fine tuning can be done.
Yeah, yeah, that's great. Any other questions from participants? Sir is open to discussion, so please ask. Sir, is this like the model? It's you are mostly specify the Kerala situations and all. So my question is it applicable for anywhere, or what are the challenges when we try to deploy? Suppose you are trying to deploy this to a north Indian state, or in European countries, or in USA. So what are the challenges you are expecting?
The thing is like the in any region we should fine tune the model. We can't apply the general developed model to any, because like if you consider the chest X-ray, I will explain you that the chest X-ray is itself, the if you consider the hilly area, uh, the the heart, the condition of the heart or the size of heart is different, because like they used to climb the what's the roads and everything like that. Like, considered like the central Kerala is concerned, maybe the hill or some other condition may be lesser. Got me? So when a model is trained on the hilly condition, something like that, the central region of Kerala will be considered like abnormal patterns. Got me? Like, even in chest X-ray, I'm not telling you CT scan, MRI, all depends. Got me? So what we can do is like, if you go for any of the particular region wise, we should fine tune the model to get a better accuracy. Got me? So what is like all the players in the market, what they used to do is like, they have a developed model. They will fine tune the last layer when with the data of the particular hospital or maybe the particular region. Okay, then only it will give an much more better accuracy, or maybe predictive level, something like that. Moreover, then is the label data should be there. Enough, if a label enough data is there, then only we can do these kind of stuff. That's a basic problem that most of the like developers are facing.
Yeah, that's true. That means a global one single model, it's not possible as per your comments, I guess.
Yeah, sure. Basically, in the case of image processing itself, like I'm not telling you LLM models can be, because like the clinical patterns, or maybe like if you consider LLM models which is generating, I would say, clinical data, or maybe predicting kind of stuff, it can be replicated anywhere, but maybe because like most of the cases, like the clinicians may be using the same pattern. If some clinician using same pattern, it can be replicated anywhere. But an image is considered like it's a region wise difference may be there. That's what I find from the market. The region wise difference is there. So but in case of pathology, images are there. It's a particular different, because like the cell level, structure level, no, I didn't find any patterns of the region cases is not there. In case of radiology and CT scan, MRI, there's a region wise dependencies there.
Okay, sir. One question from Professor Linkeshwaran. He's asking, sir, shall we use this tool for PhD work?
I don't know much more about that, like, because like this is some standard for what's say clinical literature making, or maybe clinical standardization may be there. I just want to check it out whether it can be used directly to what's say research kind of stuff. But like
Okay.
we can use something like, because like for the any model to be developed, there's an initial like, as you already know, version 1 is there. So you can use the preliminary model as an what's say for a validation purpose. Like most of them are using synthetic data. That's another advantage of generating AI and kind of stuff, because the problem that facing in the market is like we didn't have enough data to train kind of stuff. So clinical literature also is in the same condition, because like the data is not available, so that we can train the model with the minimum data and generate what's a synthetic data out of that, and from the data. But like I will not tell you like is a precision cannot be there, but it can be admitted.
Yes, sir. One more question, sir. Can you explain the issues associated with deployment?
Yeah. The deployment is like it's a primary consideration we all should consider, because like the GPU is a server, like we can deploy these models on the GPU servers only. So the hello.
Please mute. Someone is.
Hello. So
Continue.
yeah, so to deploy this model, the GPU server should be there. It's like and it's costly also, like as you know, because like all these GPU servers are costly. So we should like hire any GPU server from Google is there, maybe Amazon is there, like it will charge for uh, uh, per hour rate is there. So the model should be deployed there first of all, and after the weight should be deployed there. And like we can use the two type of request service, like services request is there. Services request is something like that. Serverless architecture is there. Serverless architecture is something like whenever a when a request is going to server, then the model and with the weight will be deployed to the server and it will run. This is serverless architecture. The server architecture is there where like we will deploy the model and weights in the system, and it will be up for 24/7. So what happens, like but it's costly way, because like the model will be up and running, so it will be charged every hour. But it's in a serverless way, we can optimize the things, like whenever we request something, then only model, like what I emulate, or maybe what I what's a show in front of you is a serverless model. Whenever a request is coming, the X-ray image along with the weight and model will be deployed to server. It will respond, then the connection will be closed, so the cost will be reduced. So what I prefer is like serverless architecture.
Okay. Anything else from the participant side? Uh, okay. So with that, we will wind up this session. And Namita, please.
Okay, sir. We thank Mr. Abhilash Raghunathan for taking a valuable session on the progress in deep learning approaches for medical imaging applications as part of the faculty development program organized by the Department of Computer Science, KMEA Engineering College. The session gave an overview of recent developments in deep learning and its use in medical imaging, showing how these techniques help in improving diagnosis and healthcare solutions. We are very grateful for his time and effort in sharing his knowledge with us. Thank you, sir.
To all participants, please fill the feedback form we already shared in the chat box. So please fill, and next session will start around 7:30.
Hello, participants. We are now beginning the second session of the fifth day of our 6-day FDP on advanced artificial intelligence and machine learning techniques for medical imaging applications. It gives me great pleasure to introduce our esteemed resource person for the session, Dr. Sumodh Sundar, Associate Professor, Providence College of Engineering, Chenganur. He was previously head at the Center for Artificial Intelligence, TKM College of Engineering, Kollam. He is corporate and ASAP trainer in the field of machine learning and data science. He has completed his PhD in the topic Artificial Intelligence in Medical Image Diagnosis from VIT Vellore after his MTech from TKM College of Engineering. He has trained over 2,000 professionals, employees, and students in machine learning, deep learning, and Python so far. He has authored textbook on computer programming and published various Corpus SCI index journals. He was previously academic relations of IEEE Kerala Young Professional. Now, he is the founding secretary and treasurer to ACM Kollam chapter. His online session on data science received Guinness Book of Records. And also, he received the Best Faculty Award in the year 2016. We are truly honored to have such a distinguished person with us today. His expertise will enlighten us and open new perspectives on diabetic retinopathy classification using deep learning techniques. With great respect, let us welcome Dr. Sumodh Sundar to lead the second session of the Day 5. Welcome, sir.
Sir, your voice is not clear. Please unmute.
Yes, is it audible now?
Yes, sir. Yes, yes.
So I think I have joined from my phone also. So I think it's clear to you. And let me share the screen. So 1 second. 1 second. Yeah, right. I think my screen is clear to you, right, sir?
Yes, yes, yes.
Yes. Okay. Okay. So I think I can start my session now. So thank you, dear organizers, for inviting me for the session. I think around we have 114 students, sorry, participants, faculties in this group now. I think you are all with me, right? Please don't switch on the video and please don't go somewhere else. Okay. So please stay with me for the next 1.5 hours. I think you were attending few sessions back, right? So I think this will be a second section today. So I think you will be tired now. I know that. Plus, but please engage with me for I will be with you till 9 o'clock, right? I will try to keep you not keeping boring, but I will try to engage you. Okay, right. So anyway, let me start with my usual things from here now. And before that, the organization said that this will be for diabetic retinopathy detection, right? So tomorrow also I will be having a session there. I will be jumping to diabetic retinopathy. So today I will be focusing on two sessions. Like one, I will give a general in overview for the AE in medical imaging diagnosis. And then I will shift to another work. So that I will that is one of my work also. So we have worked on lung cancer detection. So that I will focus on the second one, right? So I think you all know this concept of machine learning and deep learning, right? So quickly I will go through all these things in 5 to 6 minutes. Okay. So so I think everyone is you can see my screen, right? So everyone is aware about deep learning, right? Can you chat me? I think you're all chatting, right? So I am looking into your chats as well. Can you tell me what is deep learning? You know, but how much you are aware with the deep learning? Can you chat me? I can see your chats. I can see your chats. Can you chat me how many are good in deep learning? Are you good in deep learning? Yes or no? Can you chat me? And yeah, Prashant Dope is, I think we have some participants from outside Kerala as well, right? So AN and CNN, yeah, no, sir, DL, okay, fine. So please interact with me, okay? Otherwise it will be a boring session, right? So you know this, no, right? Okay, okay. Can everyone chat? I think around we have 118 participants, right? So I will be asking every questions like this. We are in the classroom. Yes, yes, you know the deep learning, right? I think some of them you know about machine learning, right? You know that, right? Only 4 people have responded me actually. Okay. Let's wait for the other chats. Okay. I think you know the concept of AI, right? And what is the? So I'm always asking, what is the relationship between AI, ML, and deep learning? This is the connection for that, right? ML is a subset of AI, and deep learning is a subset of ML, right? I always start from this session, this slide, because this is very important for your knowledge, right? And can anyone tell me what is the difference between machine learning and deep learning? What's the difference between machine learning and deep learning? Can you tell me machine learning and deep learning? You can, yeah. I'm reading your chats. Okay. Mr. Professor Prashant Dope is saying that feature extraction, right? So I think in machine learning, yeah, someone is telling that number of layers are there, right? Yes. So machine learning, it involves a lot of algorithms, like supervised algorithm is there, unsupervised algorithms there. I think everyone is known with that concepts, right? Yes. And coming to deep learning and machine learning, we have multiple algorithms are there, right? Supervised algorithm, unsupervised algorithms are there, right? And one of the algorithm you might be heard about neural network, right? So neural network is a prominent algorithm, and we have multiple kinds of neural network, ANN, CNN. A lot of algorithms are there, autoencoder, LSTM, RSTM is there, right? And we can say that the advanced neural network, that is called a deep neural network, and that we can call it as a deep learning, right? So we could say ML is a subset of AI and deep learning is a subset of machine learning. You know that, right? And what is the difference between machine learning and deep learning? Can you spell out the difference what we are having? And you can see the difference itself in my picture, right? So in traditional machine learning, we are extracting the features, and then we are feeding into the machine learning algorithm. Can you chat me about all the machine learning algorithms that are available now? Which are all the ML algorithms? Do you know ML algorithms? Can you chat me? I think in every syllabus we have the machine learning now, right? So every faculties know this concept, right? SUM is there, random forest is there, neural network is there. A lot of ML algorithms are there, right? Linear regression is there, right? So in ML algorithm, we can feed the features into that, and the machine learning algorithm will, yeah, we will find that. But in the case of deep learning algorithm, the features will be automatically extracted, right? Like as in the picture, you can see that we are feeding an image, and the features will be automatically extracted from the deep learning algorithm, all right? From that image. For example, I'm giving an image of a cat or a dog, okay, a bird or a tiger. I'm giving the image, so it will be automatically extract the features from the image. So today my topic is not about CNN, but if I'm taking a concept or a workshop in CNN, normally I will detailing go through which are all the features and how it can be extracted using the deep learning algorithm, right? So the main difference between machine learning and deep learning is that in machine learning, to the algorithm, we are giving the features, but in the case of deep learning, the features will be automatically extracted. I think it's clear too, right? Then, a lot of applications are there, right? This is all about deep learning. And just I'm giving warm-up session in the machine learning actually. Just I'm going through, brush upping all these things like here. You know that machine learning techniques are of different types, right? Supervised is there, unsupervised is there, reinforcement learning is there. You know the concept, right? And coming to supervised learning, we have multiple tasks like classification is there and prediction is there. You know the concept, right? I have summarized all these things together in a single slide. And can anyone tell me what is the difference between classification and prediction? Can you tell me the difference between classification and prediction? Quickly, I will go through this and jump to the medical imaging part. Can you share me what's can you give some example for classification? Can you give some example for classification? Yeah, categorization. For example, we have some 50 miles of dog and 50 miles of cat. There are two phases there. Right? You know that training and testing is there. So in training, we will be training with the 50 measures of cat and 50 measures of dog, right? So the learning algorithm will know that, yeah, this is cat, this is a dog, right? So when we are giving a new image into the algorithm, it will predict whether it is a cat or a dog. So that is called a classification. So this I am telling because in medical imaging cases, a lot of works related with the classification. For example, cancers are of different types. So today we will be discussing of that. Tomorrow I will discuss with the retinopathy. So diabetic retinopathy will be of different classes, right? So we will be classifying using CNN algorithms. So coming to the prediction, what about prediction? Can you tell me what about prediction, right? So I always say that the Hindus will go through that prediction, right? Because everyone will go through the astrologer and they will look up the prediction, like when I will get a job, when my son will get a job, when my daughter's marriage will be getting ready. So that's all the things we are looking into the future. For example, I have the temperature from January to November. So we from this temperature, we can predict a new temperature on December, right? So that is all about prediction. In cricket, we are watching cricket, right? So we in 40th over, the run rate will be predicted as how much run will be calculated by India in the 45th over. So that's all about prediction. So something all about future prediction is called prediction, right? So hope you got the difference between classification and prediction, right? Can you chat me? Hope you got the difference. So classification is all about labeling and finding out a new data. So what about prediction? Classification is not simply not for about images. For example, I am training the voices of Yeshudas. You know the singer Yeshudas, right? And I'm training the voices of Chitra, right? So two voices are entirely distinct, right? So when I'm training with Yeshudas songs and Chitra song, the machine will learn, right? And when there is a new song comes in, the machine will predict whether it is Chitra or Yeshudas. Hope you got that, right? And prediction is clear to you, right? And clustering is all about grouping of data. So this in machine learning scenario, we will be grouping based on the similarity, fine. But these three cases are very important for deep learning, especially in medical imaging, because when classification, how classification comes into medical imaging is like, for example, I have 5 set of classes for lung cancer. I can classify or train it using a CNN, and I can, when I'm giving a new image, it will be predict what will be the class of the that cancer, right? So second one, prediction. For example, if I'm giving 5 stages of cancer, I want to predict the 6th stage. What will be the 6th stage? We will call it a staging. So that is a prediction. And clustering, I will give a clean example of medical imaging. For example, we will having the lung cancer or brain cancer. For example, tumor is there, right? And in brain, it will be there will be some gray and white pixels will be there. But in some areas, it will be clustered. Some cancer affected areas will be there. Right? So that areas we can be clustered together. So what I conclude is like the classification, the prediction, clustering techniques we can apply on medical imaging, right? So this I will. I think it's clear to you. So can you chat me, dear participants? I think around 128 participants are there. Let it be 120. So can you chat me, everyone, please? What is classification? Hope you got what is prediction. Hope you got an idea of clustering. Can you chat me? So how it can be? Someone is doing PhD. I know that someone will be looking into the PhD. So this will be useful for them actually, right? So coming to the neural network, basically you know the concept, right? You know that we have millions of neurons in the brain. Okay, and we know that 2 kinds of brain neurons are there. So one is input. I mean, some neurons can give inputs. For example, if I want to take the mouse from here, there is an input signal should pass to that, right? And when I am crossing, when I hit with a wooden part, I will quickly remove my leg from there, right? So that will be responsive. So 2 kinds of neurons are there. So in our brain, we'll be having millions of neurons. So these millions of neurons are interconnected to us. So inspiring this idea, they have introduced the concept of neural network. hope you got that. I think 80% of this audience know about the concept of neural network, right? So let it be there. And see, neural networks are of different types. And the advanced neural network, we can call it as deep neural network. And another kind of neural network is convolutional neural network, right? So today is not, if you are interested, tomorrow I will show a hands-on part on CNN, okay? Hands-on part of CNN. So I think at the end of session, I will ask you, if you want to, do you know CNN? Can you tell me? Yes or no? Can you tell me? Do you know CNN, convolutional neural network in detail? I am reading your chats actually. Yes, I think everyone know in this time, right? CNN. Only 2 or 3 are chatting with me. I am reading your chats. Okay, let it be. So when you're dealing with images, one kind of task is classification. I have already asked. I'm reading your chats actually. So one kind of task is actually classification. For example, let it be medical image. I have told that. See, multiple type of cancerous images will be there. It will be of multiple classes actually. So we can group into various classes, right? Another thing, localization. So if you want to identify a particular position, so where the cancerous cell is affected or where the cancerous part is there, right? So we can find out the area. And a similar kind of task is actually object detection. So how many are you hear about YOLO? How many are aware with YOLO, YOLO, YOLO? Can you chat me YOLO? Oh, YOLO is an object detection algorithm. How many of you know YOLO? I'm waiting for chats actually. How many of you know YOLO? Anyone? Yes or no? You know YOLO, right? So YOLO is an object detection algorithm, right? So YOLO detection algorithm is there, right? Yes, you have heard about that, right? So one task is classification, one task is localization, and localization. What is the difference between localization and object detection? If you want to find the particular the position of the cancerous affected image, so that is localization, and we can assign the object. But for example, this is a cat. So this is a dog. So we are specifically identifying the object as well, right? So that is called object detection. Localization is simply finding out the areas with the pixels are affected. But object detection is finding out which is object. For example, this is a cancer 1 type, cancer 2 type. So that we can find the detection. And another one is segmentation, right? So this is very important in the, for example, tumorous affected area. We can group the pixels together. So two kinds of segmentation are there, mainly semantic segmentation and instant segmentation. So instant segmentation, you can see that the pixels are grouped together based upon the intensity, but it is separated together. For example, if this is in the case of a semantic segmentation, I will show you like it will be like in this way. It is way, right? It will be, so this will be grouped together, right? It will be grouped together. So if this kind of segmentation happens, that is semantic segmentation. But instant segmentation will segment or group the pixels together, but it will individually identify the objects as well, right? So it can clearly distinguish. So dear participants, hope you got an idea of classification, localization, detection. Mainly the difference between localization and detection as well as segmentation. Can you chat me yes or no? How many you got that idea? Segmentation, detection, localization. I'm waiting for your chats actually. Yes. So I'm moving to the next part. So if you are, I think there are some of our beginners with CNN, right? For example, classification, I could use a technique called CNN, right? For if you are a beginner, you can note it down. For a classification, I could use a technique called CNN. And for localization, I could use some technique called YOLO. For object detection and CNN, right? For semantic segmentation and instant segmentation, in medical imaging, there are some techniques called UNet is there, UNet, and VNet is there, VNet. If you are doing PhD, it will be helpful for you, right? UNet and VNet, there can be used for, especially UNet and VNet is designed for medical imaging, right? Some microscopic images they have trained initially. Yeah, someone is asking that the order will be classification, segmentation, and classification. Let it be there. I will tell you how it can be progressed. For example, if I can classify into a cancerous affected or cancerous not affected images, so that is classification. So that cancerous affected images can be taken for segmentation. So that's up to you. There is no kind of order, because even though we could perform some localization, we could crop the images, the image area from here, and that can be fed into CNN as well, right? So again, So instead of giving a 224 into 224 image into a CNN, we can localize that area, let it be 20 into 20. So that 20 into 20 area can be fed into classification. I think Vivek Kumar, Professor Vivek Kumar is asking that. So even though sometimes localization will help us, after localizing and cropping that area, we can feed into classification. So it's up to the task what we are having. Sir, is that clear for you? So there is no specific order for us, right? It depends upon the data set. It depends upon the task we want to do. Can you chat me, sir? Is that clear? Yes. So let it be. I think if you're a beginner, you can note it down, and if you already know the concept, okay, please please hear it for the next time again. Okay. So let me go through that. So how? So can I move to the next one? So classification, localization, detection, and segmentation. So I think if you are organizing a PhD thesis, you can have these on your multiple chapters, because I'm giving you, when I was a beginner of PhD, at that time I was struggling for how to organize my thesis. So then a professor told me on this way, so it helped me. So this will be helpful for you, right? Let it be. And how the medical imaging happens, help us. So we know that a lot of applications are there for AI in our lives today, but you can see that when you're taking the AI cases in healthcare, it will be a lot of, I mean, for example, robot-assisted surgery is investing, getting a lot of investment, virtual nursing assistant. So a lot of applications, you can say that it is related with the medical case, right? And I think the India, some other countries are working in AI for their securing, I mean, to enhancing their security applications, right? So anyway, medical imaging, the security kind of applications plays an important role. I mean, through AI. So can you chat, mute yourself, please? Okay.
Sir, your voice is not clear. You just to unmute
Oh,
other
sorry.
one.
Now it's clear, right? Now it's clear, right? So,
Yeah.
so I think in the previous slide is clear to you, right, sir? This one is clear, right?
Yes, sir. Yes.
Right. So again, why we require AI in medical imaging is that we know that we in previous college where I was working in TK college, there we have association with some hospitals nearby. So they have given some data sets for us, and we have done some applications we have developed, and we have given for that. And another one, why we require AI in research areas that, see, a lot of two kind of data sets. For my PhD, I worked in diabetic retinopathy. So that time I have collected the public data set from the internet, right? And then I worked on the real-time data set collected from the nearby hospital. But in the case of cancerous kind of data, lung cancer kind of data, so there is the data is very challenging because of the modality. Hope you got about the modality, right? Have you heard about modality? Various kind of modalities are there. Can you tell me what is modality? What I have meant for? I'm waiting for the chats actually. Can you tell me what is modality of an image? Modality of an image? A hybrid. I will give you some examples like X-ray is there, CT, PET CT scan. So MRI images are there, right? So I think it's clear to you, right? So different type of modality. So it will be very challenging. Some kind of 3D images. It is very difficult to process. So we require some artificial intelligence technique to detect all this, right? So we know that we need some tool to visualize what is the I mean, some tools we require to identify. For example, have you heard about slices of images, right? When we are taking MRI images, see, images are of different types. JPG images are there, right? Sometimes images will be CT images. Sometimes it will be MRI. Okay. Sometimes it will be X-ray image. For example, we worked in COVID data set, right? So that time we have worked on X-ray data set, right? So sometimes if you're taking an MRI, it will be of different slices. Okay, 3D slices are there, right? So the presence of the cancerous affected will be see, imagine it's like a cutting an onion. Okay, cutting an onion. So that I will call it as slices of MRI, right? So we can find out the affected area if we are going through the deeper slices of it. So there we couldn't find any cancerous affected area in the first slices. Okay, it will be in the deeper slices. So there we required some AI tools for visualize all this. Okay. And a lot of modalities I have said that. So if you are getting into research, you should know about the modality. X-ray is there, CT is there, MRI, ultrasound. This is a prominent one. And then you are working in the case of images. Okay, when you are working in the case of images, right? So another thing, someone will be working in. So my MTech students were working in. We have some publications for the signals. I mean, we have some signals. It will be EEG signal, ECG signal, and EMG signals will be there, right? Mostly they are working on electro EEG signals they will be working on, and some images, some applications for medical imaging using AI is all about 3D reconstruction, right? So 3D reconstruction means, for example, if you're capturing some images, some of the parts of the images will be lost due to some reasons. But at that time, we can reconstruct the images using, hope you heard about GAN. Have you heard about GAN? Can you chat me? Generative Adversarial Network, GAN. Can you chat me? Can anyone? GAN. GAN is there actually. So some auto-encoder techniques are there. So now we have a lot of generative AI techniques are there. So we could reconstruct. So some images will be microscopic images, right? So this if you are approaching for some PhD work or research, this kind of modality. I mean, someone could focus on. If you are interested, you could work on radiology images. If you are working on signal waves, you can work on signal. Sometimes you can work on microscopic images and the 3D. So I just mentioned about this modality is very important, right? So I think it's clear to you, right? Shall I move to the next one? I think it's clear to you, right? And beyond that, a lot of modalities are available in the medical imaging sector. So these, see, if you are looking into these work, the works are very limited in most of the modalities, right? Every time we are focusing on this CT, MRI, and I mean EEG kind of data, right? So a lot of these more modalities other than this, right? So I think you can focus on that. So these are all some of the data type of set. So sometimes instead of we know about CT images, right? Sometimes we know about MR, right? Sometimes we know about ultrasound. But beyond that, we have another kind of modality, PET images, positron emission topic. Today I will discuss about that also. If not possible today, tomorrow I will show you that, right? So let it be there how the time looks going on, and this kind of modalities are also available because this kind of images contain different kind of features. So X-ray contain only limited features, but MRI contain deep features. So sometimes that deep features will help us in correct classification, right? So at that time it will be very, on the other part it is very challenging as well, because we want to find out the right set of techniques to find out the deeper techniques for that, features for that. And let it be, if you are a beginner, I think this will be a help for you. Is that okay? Can you go through this? How the medical imaging process, the work in there? Acquisition. What is acquisition? What is acquisition? The capturing of data, right? So sometime when you're writing the paper, this flow will help you, right? And the digitization, make it into, I mean, scanned version. I mean, we will be able to get in our computer. And some kind of pre-processing techniques are there, right? So normally I have told about the classification technique. Okay, sometime I will be extracting the segmentation technique. Before that, there is an important technique called the feature extraction, right? Anyone taking notes? Can you chat me? Anyone taking notes with me so that I can arrange the session like that? Are you taking notes with me? Can you chat me? Or simply you are listening? Yes. So I think you can note down these things quickly. Some techniques you can focus on classification, and that will help us in interpretation measurement. So when you are drafting your PhD thesis, I think this flow will help you, because what is the purpose of classification? This you can use it for interpretation, proper interpretation. So it will assist the doctors, right? So same time measurement, it will assist the doctors to have the correct measurement of that. And before that, we are behind the we could do the segmentation feature. So feature extraction is very important, right? Very important. And before that, we have some techniques like calibration, adjusting the machine, and registration is very. See, if I think the works are very limited in registration, so you can go through that as well. And a lot of techniques are there. Surface reconstruction. I mean, the reconstructing the essential part lost, right? So elimination. So I think you have noted down, or you may take a screenshot from here, right? So a lot of techniques are associated with it, right? Is that clear? Shall I move to the next one? Right. I think we have lost I think we have approached 8 o'clock, right? Right, let it be. So I'm moving to the next one, all right, with your permission. Right. So various factors are affected with this medical. So some factors like, so have you noted down? Do you need some time to note it? Are you noting down? Shall I wait? Can you chat me? So I'm confused that whether you are right, done, right? So I think I can move to the next one, right? Yes, yes. Okay, you took the screenshot, right? Okay. So I think a lot of factors are affecting the medical imaging part. Some of the main challenge, is the data acquisition device. So this is one of the questions I have received from the doctoral committee. Is actually they have asked that how you took the real-time data. So I have told that I got the data set from the hospital, but they told that how it can be. I mean, they need to value that. I mean, how whether it is approved by the doctor, right? So whether have you gone through the ethical committee, like they're asking. Whether I got the consent from the patients, like how you approve the data set in an ethical committee of the hospital. Like that. And another thing they have asked that whether the data is calibrated. I mean, whether the device can be standardized one. Right? So this is one kind of challenge actually we are having. The machine actually what we are capturing. Right? And for example, how it captures the frequency of applying the machine on the body is important. And the size of the, for example, I can give 224 into 224 image. So that is a kind of size. So someone will be working on 110 into 110. Right? So definitely both of the experiments will give different kind of results, right? Sometimes 224 into 224 image. So that time the presence of the cancer will be here, and sometime 110 and 110 the cancer will be here. So definitely the resolution. The first part is resolution. Second part is the size. Third one is the place that the object is affected, right? So that matters. So these are all the various factors related with the medical imaging. So this will be real challenging if you are dealing with the real time situations, right? So various applications we could use. For example, in the skin also we can identify the uninfected area. Sometimes we could go for the affected area. We could classify them. And another one, the localization. I have already told you. This is another kind of research topic actually. Some can work on here. Sometimes some mass content or some the content is this present in our body that can be localized where it is located, and you can see that these are all anchor boxes, right? This is anchor box. Anchor box means we can identify the position where it is located, right? That is called the localization. And segmentation. Segmentation is all about. You can see that I have already said that we can group up the pixels together, right? So we can group up the pixels together, right? So and the grouping up of pixels will help us to identify the intensity of the disease what we are having, right? So this is all about segmentation and grading. This is another type. So this is all about grading of kidney diseases. For example, the kidney diseases will be of different levels: mild, moderate, severe level, and this can be classified in various grades: grade 1, grade 2, grade 3, grade 4. So this we could use for classification, right? So the grades can be different classes. We could identify the right set of grade, right? So this is another. So this is all about kidney grading. Okay. And another one we could the AI application is 3D modeling. So this, see what we are saying, that like the most of the research topics in the AI medical imaging is saturated, because if you are taking most of the publications, it will be related to AI medical imaging, right? So it's almost saturated. So it's very difficult to get a publication nowadays. So if you're looking for some good publication, we could use some 3D modeling, right? 3D modeling. So 3D modeling is means that we can reconstruct the affected areas, right? So another applications like lung cancer detection is there. So we can, lung cancer detection is there. So we can identify the presence of lung cancer. And another one using the ECG. So when we are looking into the ECG signals,
Sir, you are muted.
we can identify the diseases from the ECG signal, right? Another one using the lesions. Lesions means we can identify whether it is affected or non-affected lesions, right? So another one is retinopathy. This is my work, diabetic retinopathy detection. So we can classify diabetic retinopathy into various classes actually. So that I will try to explain tomorrow, right? So this is another application, right? It's very clear, right? And tumor detection and blood flow visualization, whether this blood is flowing on the right set of hair. So that is blood flow visualization. And so this drug discovery, they could use it for various tasks actually. And another one, the various challenges medical image processing, like spectral noise is there. The spectral noise means sometimes the noisy affected, the images will contain some noise, right? So these are some challenges. So this can be solved using filtering. So if you want to reduce the computation time, you could use a technique called a registration, right? And these are all some sort of challenges and the solutions we are having, right? So I think it's, oh, I'm unmuted, right? I think it's clear, right? Is it audible?
Yes, sir.
Yes. So I think I will jump to my main topic today. So you can note it down by various research areas. So you can work on different imaging modalities. You could work on various image processing techniques. So image registration, hope you heard that registration techniques. And organ localization is another domain. And organ segmentation is a image classification and retrieval, digital angiography, 3D optical micro, and digital pathology, right? So digital pathology is a good area where you could work the latest work there, right? Actually, so you could, if you want to some good publication, you could work on digital pathological images are there, right? So these are all the various research areas where you could try, right? This let it be there. And some of this is like an intro part, okay, actually. So really, Google is working with Aravind Eye Hospital. Aravind Eye Hospital is giving the data set, okay, the data set for the real-time detection also. So how it looks like that, I will show a picture now. And very important part of the data imaging technique using medical imaging is that image processing technique. I mean, pre-processing technique is there. Because most of the challenges with the real-time images is that it may contain some affected areas. It may contain some noises, right? What is noise actually? Can you tell me what is noise actually? These are some abnormal patterns available in that images, right? So how it happens because of that? Can you tell me how it happens actually? It is might be happened upon the lighting conditions, poor lighting conditions, poor setup conditions. I mean, the way it is captured is very poor, right? So various ways it may result in the noisy affected. I mean, it will result in noise. So that should be properly removed. I mean, image pre-processing is very important, right? So another technique segmentation is already you have heard about, right? So text segmentation, if you are a beginner of segmentation, you should know that pixel-based segmentation is there, boundary-based segmentation is there, region-based segmentation is there, and hybrid-based segmentation is there, right? So this kind of, see, if you are working on segmentation only, you can write it for 1 or 2 chapters. Someone can work on pixel-based and boundary-based, and someone can work on region-based, and one chapter you can work on region-based and hybrid-based, right? So these are some of the research areas you could work on. I mean, you could work on segmentation on tumor, right? Segmentation on lung cancer, you can do that, right? Anyway. And another application is a fractal analysis. So simply we don't need to go for images only. We will be having signals. So you can collect the EEG signals collected from, so some devices are there, right? So in previous college, TKM, we are having a biomedical lab is there, right? So from biomedical labs, the rods are connected to the brain and the signals will be real time collected and they have done the analysis and actually they have developed a new hardware to identify the to classify the signals, whether it is, it is affected or not, right? So, they can identify the disease what they are having, right? So, the hardware part they have done, the A part we have done on our center of A actually there, right? And this is actually what I have done. I have given some retinal images and through the CNN, we could classify the classes of diabetic retinopathy. And this is actually another application. You know about fetal imaging, right? So in some kind of research works, see, these works are very limited. If you are taking the PhD works all over here, everyone is working on lung cancer, diabetic retinopathy, that brain tumor classification, everything, right? And these works are happening in fetal imaging, this kind of, because you know that the presence of, the presence of, baby inside the belly will be in different positions, right? So we could identify whether it is in the right position or not. That we could identify using a technique called registration, and there is a technique called resolution, super resolution. With the simple images what we are having, that pixels node will be a good one, right? So we could apply a technique called super resolution, and we could regenerate it in a better quality. So that we could do some work. I have seen in the placenta segmentation as well, right? So this is another application whether you could do work of, right? And this you can see that the position of the, the position of the fetus can be easily identified through some fetal segmentation as well, right? So this is another good work actually, but the data sets are very limited actually for it. But it is very good if you are trying to do that, right? And another one is like brain cancer segmentation and brain image registration, and you could regenerate a 3D model from that. So these are the applications you could try on that area as well. And this is very one of the good work I have, my MTech student have done that actually. He have regenerated, for example, have you heard about ground truth? Can you tell me what do you mean by ground truth? You can see me, right? What do you mean by ground truth? What is ground truth? Can anyone tell me what is ground truth? Can anyone tell me? I think some of have done already PhD from here, right? Ground truth. Can anyone? Yes or no? No, right? See, I'm running fast actually because I thought that you know deep learning, that's why I'm running fast. Yeah. Is that okay? Is my session, is the phase is correct? Yes or no? The speed delivery? Yes, it's okay, right? So I'm running fast. Okay, I felt that. Okay, let it be there. And Mr. Rafiq, I think Rafiq sir is HOD, right? So Rafiq sir is saying that the mask generated by the experienced radiologist. See, actually, ground truth. See, that's the correct answer actually. So ground truth is the, what to say that it's a blueprint. Actually. So, for example, if you want to do some segmentation, where we want to find out perform the segmentation. Or if you want to identify, for example, I have 10 images of a cancer affected area. And I have some mask, right? I have some mask. And for example, I want to do some localization. I want to do some localization technique. So I want to specifically locate it where it is affected, right? So here I want to locate here where it is affected. So that time, if we have an image, I will be having another ground truth image where this ground truth will be telling that, yeah, you should look into this area where the presence of cancer will be there, right? So that ground truth. So ground truth will help us to look not help us, it will help the CNN model or the deep learning model where to locate. So that is called ground truth. So what is synthesis of ground truth? What I have meant is like, if you have a ground truth, we can regenerate what the images look like. So there is a technique called the autoencoder. Does anybody know about autoencoder? Have you heard that autoencoder? Can you tell me autoencoder? I think some of them have taught a autoencoder in their syllabus, right? Anyone? Yes, right. Autoencoders, we can regenerate the image, right? So this is an application, and this is kind of the startup they are working in AI, Biodigital, Mevis Lab, and Niftynet Oyo. These are prominent medical AI applications, right? And Enlitic is a startup that uses deep learning in medical image, right? So Enlitic is a startup. Then IBM works with the AI-powered technology for actually they work for COVID detection. And this, please visit this site actually. How you open the site with the see, have you tried this one? AE.Google. So please go to this site and you can see that we can give our own inputs. So we can give our own symptoms. So use that symptoms. Google AI will predict our heart disease, right? See, we can give the parameters like that. So please, this is a free application now. So please go to that. This is a wonderful application. And this I have told that this Arvind Eye Hospital is working with the Google, so they can predict the class. I mean, they can look into the diabetic, so they can look into the retinopathy features. So how to look into the retinopathy? Why to look into the retinopathy features is that using the retinopathy features, you can identify the age of that person, gender of that person, whether he will be smoking, that BMI index, all these things can be calculated. Systolic blood pressure. I think it's clear too, right? So this is very critical, and this will be helping us. So if you have a retinal images, we can calculate all these things, right? And this is another side you can give health.google. So this is Google, I mean, health assistant technique actually. So this is powered by AI. And Siemens work on, they work on a product called AI company. So they work on chest CT images, right? So you can look into the site of Siemens actually. So you can get the info from there. And this one also. And Vuno is a startup that works in. So you can go to the site and there you can work on the medical imaging data. You can deploy some algorithms and they provide some software for using that. Vuno is a software, and IBM Watson Health is a prominent area where you could they work on AI for a health part. So works against cancer. Actually. I mean, IBM Watson Health. I mean, cancer detection, classification, all these things. And Babylon chatbot is a prominent chatbot. Like, so we can chat. Okay, like to the chat GPT, we can chat to the chatbot where we could. They will be giving. Actually, they will be giving some prescription. So personally, I will say that don't go for the medical shop using this prescription. I don't guarantee for that, right? So anyway, we can act as a. See, I think now the era of chat GPT, right? So you can get in the chat GPT. So chatbot, Babylon chatbot, I have just mentioned only. So this is one of wonderful technique actually, prominent work actually, skin cancer detection using deep learning techniques. So the Stanford is working on that actually. Hope you heard about who is that person? Andrew NG, not Andrew NG. I mean the co-founder of Coursera, Andrew, right? So he's a great person in deep learning, right? So I think Andrew NG and his team is working on that, right? And has worked on this area. So this is one of the good techniques you can try for PhD, skin cancer and melanoma detection, right? So sometimes some works are based on histopathological images, right? So phase 2 gene, when you are giving the images of a baby, it will identify the algorithm will identify what disease the baby is affected with, right? So this application is phase 2 gene, right? Phase 2 gene. So it will identify the rare diseases when we are giving the picture of a baby there, right? And another one, if you are starting with the research, so this will be a good option. I mean, this will be giving some medical information about medical imaging repository and some this all kind of. So I think you can take some screenshots. You can go through this site. Some information about the medical imaging data set and the techniques are available there. So let it be there. And these are all the see, when we write some papers, now trust me, now it's very difficult to publish papers in AI in medical imaging because because when we send some papers to that, it is it's very difficult actually. So what I suggest is that if you want to write, if you're a beginner, if you suggest our students, better not to Google, just to go to Google. Instead of directly go to Google, we could use these journals. For example, these are some prominent journals available related with the medical imaging publications. I mean, these works contain AI in medical imaging techniques, right? So you can take these journals for a go through, and there you can see some publications actually, right? So you please take the screenshot actually. This will help you in reading and getting papers. At the same time, you can try the publications there. Okay. So is that what can you share me? Hope you got beneficial, right? Right. Another site is deep learning AE and AE for medicine. You can take that page, right? So is that okay, medical? So can you share me? Right. So how to deploy that is you can use some platforms like Amazon SageMaker, is right? Amazon SageMaker is a online platform where you could deploy your dataset and medical imaging on a big scale. Otherwise, you require some server, right? So might be you have heard about Google Colab. Before that, you could try your own dataset and your own images in your own system. And hope you got the difference between CPU and GPU, right? Is that okay? Hope you got the difference between CPU and GPU. Can you chat me? CPU and GPU. Yes, right. Nobody's chatting, right? Are you with me or yes, right? Sometimes your system may contain GPU, right? Otherwise, you need to go to some servers or you need to purchase some paid versions of Colab or something. So if you have some GPU facility in your computer, you could run a bigger data set. If you can install Spider or Jupyter, I know that you know that this will be a platform for Python, right? And see some funding options for maybe projects are there. So DST funding, CTAC funding is there, right? Some better funding options are there, right? So you know that, right? So please take it down. So you can go to their website as well, right? And what I have worked on recently is that I have worked on retinal image segmentation, classification, the grading where I could segment into various parts and I have done grading. And you know that. So you know that this will be various tasks associated. So please note that for classification, CNN is there. For detection, you could use RCNN, FastCNN, FastRCNN, YOLO is there. Okay. For time series data, RCN, LSTM RNN will be helpful for that, right? Sometimes we'll be extracting the features, right? So this I am telling you, this is my first session. This I'm giving the intro part where AI in medical imaging can be used, right? So I think we have gone through various techniques or the areas we have explored where the AI can be used in medical imaging, right? So this sometimes this will be helpful for your research, right? So I am telling that this is my first phase of my session today. All right. So I think I can move to the second session where I could focus on the lung cancer part. So focusing on the work we have done recently. So this we have got some publications. So I have summing up all these techniques together. So what I have done, what our team have done, and I will showcase along with you the results, right? So dear participants, I think my first session is over today, and I'm moving to the second session. Before that, can we take a 3 to 4 minutes break just to take off your eyes from the laptops? And is that okay? Is that okay? I think we can take a 3 to 4 minutes break. Okay. I think we will be joining in 3 minutes. Okay. Okay. Thank you. Take some break, have some water, and come back. Okay. Thank you. So shall we start back? Is that clear to you? Can you chat me? Is that clear? Is the audio clear, right? Yes, right. So hope you have joined me back, right? Yes. So I think we can start now. Right. I think it's clear, right? So next part we will be looking on specifically on, lung cancer detection, right? So we can use the lung cancer data set for detection as well as the classification, right? So I think you can see my screen and here why we record for lung cancer detection. See, actually, now I'm going to consolidate our 2 or 3 works together, and I will show you how we can do that. So how we have done. So why we record for lung cancer is that, see, we know that lung cancer is a challenging issue and the abnormal cells are growing in a bigger, a rigorous way. So I think I got a question in the chat box. Can I take that? See, I think Professor Vivek Kumar is asking that. Masking. I think everyone please go through that chat actually, okay. Masking of images are a critical task. One can mask without consulting radar. I mean accurate masking images. Mask created by Level Studio were discarded by experts. Is there any way to convince experts? Okay. See, actually, different kind of data sets are there. One is public data set. So public data set is how we can take the public data set. Sometimes we could take some data set from the KAGL, but we could rely on that. It is available for, it's given for this competition. Sometimes I think I missed the website name. So that site contain all the cancerous achieving, cancerous archive, I think, right? So, lot of data sets which are available for competition. So that we can directly use that type of image data set contain the mask provided by the expert. But when we are doing some real-time data set, for example, if I am taking some data set from the hospital, it will be, most of the time, 95% it is not masked. Masks are not there. So we need to manually done the masking process, or we need to do the localization process by some, doctor expertise only. Okay. So with some expertise opinion only, we could do the accurate mask creating the image. Otherwise, they should do that. But in most of the cases, they won't do that. With their assistance only, with the help of some junior doctors, I have done that actually. So that is the only solution. So I think Dr. Vivek, Professor Vivek, I think it's clear, right? I think, hope you have heard that. Okay, I'm waiting for a chat. Okay. Anyway, I'm coming back to the lung cancer. Why we required for lung cancer detection is actually, I see this part will be containing more technical session. Okay, more technical words will be there. Okay, so I will go through that. Okay, so sometime it will be feel difficulty for you. So, and why we require for some lung cancer detection is that it is very, it is tremendously high. See, this 6.9 and 5.9 is very alarming actually. Even though this is small value. So this is very important. And when we are looking into the cancer statistics, with this kind of breast cancer, cervix cancer, ovary cancer. So this you could take. See, sometimes you could work on this one. Okay, this will be some research topics for you. Breast cancer is one, cervix cancer, ovary, corpus luteal cancer, and lung cancer, thyroid, mouth, esophagus, gallbladder, and stomach cancer. So this they could, the separately female and this alarming topic for you, right? So can I take another question in the chat box? Could you please suggest some research scopes on retinal? Yeah, definitely. So I have worked on retinal fundus images, but it is actually saturated. Okay. We'll be having fundus images. A lot of data set is the RIDE data set, which is open for competitions actually. And another one is, actually I missed that. I think because I was going through a lot of times for each and every data. See, a lot of data sets are there. So what I meant is that I worked on fundus images. Fundus is a kind of, set of images generated by some machines. Okay. And another one was, that kind of OCT images, right? OCT images. So these are the research areas there, right? So please work on the fundus images, right? And coming back to your cancer, see this kind of cancer. So today I'm working on I'm telling about the lung cancer part, right? So how lung cancer is happening because of the reasons like the excessive smoking, you know that right? Someone is smoking outside there and nearby to us, and it will affect us. And some kind of radon, I mean, asbestos, you know, right? Some kind of radioactive material, not radioactive, some harmful, I mean, that asbestos, it is creating, I mean, it is very sensitive to our nerves actually. So it is getting into our the inner part, and it is very severely affected, and air pollution, of course. And how it look like is that it will result on cough and chest pain, all these things. I mean, breath affected issues, right? And sometimes it will affect in the weight. So severe causes like the swelling of the face and neck, right? So this part I'm going, I see I'm presenting to you in a research pathway, right? I mean, kind of a research we am telling and explaining, because this is kind of work we have published few months before. Okay, and another kind of imaging, I mean, which are all the modalities if you are working on lung cancer is all about. Sometime chest X-ray you could take, CT scan. Hope you have anyone heard about PET scan and PET CT? Can anyone share me? PET scan and PET CT.
Yeah.
Yes, you, so can share me in the chat box. Can anyone? PET CT or PET scan? Yes, right? So these are all very kind of imaging modality, right? Yes, yes. And how it can be used is that if we can identify the right set of diagnosis, we could use it for surgery, radiation, and chemotherapy. So it will affect the, I mean, it will assist the doctors to do all this, right? Anyway. So what I am focusing is the lung nodules. What is lung nodules? In the picture itself, you can see that this is a normal image what we are having, and there are some small tissue abnormalities. But you can see that. See, when you are looking into the image into the computer directly, you could say that, see, these are all, we couldn't identify, these are all white pieces, right? White set of pixels. But you can see that even though this is a white set of pixel, it is the affected area where it is marked in the yellow border, right? So this is the area where, see, before training the CNN, we should mark the area where we need to look into that, where the CNN need to look into that, right? So that area we should mark, and that is the lung tissue abnormality. See, mostly it will be around 1 millimeter to 30 millimeter. I mean, it will be a small piece of area, okay, actually. So that presence will be leading to that. I mean, detecting that kind of area that will help us to identify the cancerous in the, I mean, in the earliest stage, right? So, and another thing, sometimes it can be easily, someone is not malignant actually. Someone is benign actually, right? Someone is, I mean, someone is benign and someone is malignant. Someone is affected and someone is not affected. Give me 1 second. 1 second. Right. So this is a relevance for identifying the lung disease, right? So I have some chats in the message in the chat box. Yeah. OCT means I have no set source. I don't know actually, Professor Reggie. Yeah. Professor Suraj, radioactive material is used to try. Okay. Fine. Injection is used. So coming back to lung nodules, it is very important to identify. It varies. So I mean, it will be available in different sizes. That is a very challenging task. And if you have taught CNN and if you are known about CNN, you know that CNN can work on a technique called translation invariance. Translation invariance. What do you mean translation invariance? Can anyone chat me? What is translation invariance? Can anyone chat me what is translation invariance? CNN has a property of translation invariance. Can anyone tell me? You know what CNN, right? CNN is convolutional neural network, and it is a deep learning technique, right? And it is a translation invariance means the object might be appear on different parts of the image, right? So, for example, I will show you quickly. Like sometime, for example, we have an image. For the image one, the cancer will be affected here. Sometimes the presence of the cancer will be here, right? The cancer affected area will be on different parts of the image, right? So we need to identify all this kind of area and we need to detect where it is available, right? So that is translation invariance issue, right? So that we need to solve. And how the nodules need to be categorized. One kind of categorization we can done by using the intensity. The nodule can be categorized, if we are categorizing by intensity, I mean, you can see the picture itself, right? The intensity is entirely different, right? Entirely different. So that we can classify, and based on that, we can say that solid nodule and ground glass nodule. So this intensity is higher, means you can see that there is completely opaque. This is not transparent, right? It is very thick actually. So that is solid nodule. And ground glass nodule, that technical term actually, it is very partial opacity. It is, underlying structures is visible there, right? So hope you got that, right? This kind of nodules we can classify. Solid nodule, ground glass nodule is there, right? So these nodules are categorized based on it. Is that okay? Can you follow me? Are you hearing me actually? Right? Do you hear me? You can hear me, right? You're following me, right? Yes, right. Then, based on the location, we could classify into various parts. So, based on the location, in the sense, you can see that. See, first one is we are getting into some technical topics now. Technical words I'm using. The first one is a pleural tail. So that kind of nodule is actually, see, as I told that, it's just have a tail connected to the pleura. This is a pleura area, and it's a small tail connected to that area, right? You can see that. That kind of classification, kind of nodule we can call as pleural tail, right? The second one is juxtad vascular. In the blood vessel, this is the blood vessel area, and there you could see that this is spread here, right? And the third one, this is on actually on the pleural surface itself. See, what I am telling specifically because of this kind of classification is that, so these are all very challenges. See, when we are looking using some human eyes, human can identify that, or a doctor can look into the scan by putting some lights, he can identify that. But when we are doing some A kind of diagnosis or a training, this is very challenging, right? Because you know that, see, pleural surface is actually white area, but this affected area is also, it's kind of white. So this is not clearly separable, right? So it should be properly done. Another one is well circumference. So this is actually very good actually. So it is easy to recognize because it is separately from the, evenly separated from the pleura. It is currently isolated here, right? For the black area, it's clear visible. So that is well circumscribed area, right? So pleural tail is there, juxtavascular, juxtapleural, and well. So, dear participants, can you chat me? At least one or two can chat me. Is that clear to you? So, based on the intensity and based on the location, we could do some classifications. Yes, right. So, every time, because asking because of I want your feedback and couldn't see your faces, right? We are sitting in different parts of our India, right? So, you are from outside Kerala as well, right? Anyway, coming back to the lung cancer type, this is very important. Okay, can you listen to here properly? So these are all very kind of different type of classes. See, what is NSCLC? What is SCLC? That I will explain there actually. Okay. SCLC is actually small cell lung cancer. Okay. NSCLC is non-small scale lung cancer. And non-small scale lung cancer type again classified into adenocarcinoma, squamous cell, and other kind of the third category we can group together. Okay. So here you can see that we can detect this kind of two classes. In that class, I could say that this is 1, 2, 3 set of classes. So why I am showing this picture is because it is very valid for required for male as well as female. Right? Is that clear to you, right? So coming back to our topic. So what is SCLC? It is small cell lung cancer. What is LCC? So this is small cell lung cancer again. Lung cancer based on the histological subtype. Already we have seen two types. One is based on location. One is intensity, right? So now we have seen that this is based on the subtype, histological subtype. So this is small scale lung cancer. This is large cell carcinoma, and this is adenocarcinoma and SQC. That already I have said that, right? I have told that, right? So 1, 2, 3, 4 kind of classes. 1, 2, 3, 4 kind of classes, right? So you can see that, right? So these are the another kind of class. I think you are following me, right? You are following me. Again, this is another topic which you want to do that. TNM staining. TNM is, what is TNM staining? Just I have mentioned about the, so what I have already, I will summarize again. Based on the intensities, various type of nodules we have seen. Based on the locations, various nodules I have seen. Various type of cancer classes I have seen, explained you. Another one is based on the histological subtypes I am telling. And now the TNM staining. See, when I have expressed all these things, I will summarize it for together, right? T. T indicates the extent of primary. N, the lymph node involvement, because sometimes the lymph node in the presence will lead to the cancer. Right? The M, the stage, I mean the metastatic disease, is a kind of grade actually. So T, N, M plays an important role. What is the class of that affected cancer, right? So how I will conclude all these things, like, so I will start with the T, okay, the extent of primary tumor. So T, based on T, it is first one is all about T1, T1, T1. See, T1 means if the tumor size is less than 3, so we can tell that this class is T1. It's clear too, right? And again, that subclasses are there. 1 centimeter to 2 centimeter, less than 1 centimeter is T1A, 1 to 2 it is T1B, 2 to 3 is T1C. So again, we have 3 subclasses, right? Again, 2 to T2, I mean 3 to 5 centimeter. So it is in the pleura part actually. I mean, it is not visible directly. Sometimes it will be involved in the bronchus in the bronchus part. And again, it can be classified into T2A and T2B, right? So, I mean, we are running out of the time. That's why I'm going quickly. T3. If you're interested my session today, you please attend tomorrow as well, right? Okay. I think it will be beneficial for you. So tumor size is 5 to greater than 5 to 6 is T3, right? It is, I mean, it is embedded in the pericardium area of the area, right? So again, T4, if the tumor size is greater than 7 centimeter, it will cover the diaphragm. So based on the T, we can classify T1, T2, T3, and T4. So what I have mentioned is that based on the extent of the tumor, we could classify into various classes. Dear participants, is that clear to you? Right. So another one, N and M, right? N and M, right? N and M, lymph node involvement, right? N and M. N means regional lymph involvement. So again, the N are of different type. N0 is there, N1 is there, N2 is there, N3 is there. So N0 is a stage actually where node metastasis stage is there. So if the metastasis is in the pulmonary or hilar nodes, it will be on N1. And if the metastasis is on subcardial nodes, N2. So actually I missed to add the pictures. That will be easy for you actually. So anyway, based on N, we can have the multiple classes there. And M also, we can have multiple classes, right? So these are based on the extent of the cancer what we are having and the position of the cancer what we are having, right? So T is there, N is there, and M is there, right? And together, this is the overall summary. So, what I have conveyed so far to explain this slide. Based on the T1, T2, T3, and T4, and sometimes it will be N0, N1, N2, and N3, we can group the classes. And for example, T1 and N0. So this class is IA1, and this class is I1, I mean 2B. I mean, sorry, 3B, 1A2, 2B, 3. So we can have 1, 2, 3, 4, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So 33, I mean 44 classes are here, right? So based on the TNM category, what we are having, right? So can you take, if you are looking into some cancerous area research, so you could take a screenshot from here now, right? Is that clear? Lung cancer stage groups are there, right? I think clear too, right? Okay, so just I will revise for you based on TNM staging. You know that based on TNM is there, right? So based on TNM, we could do this one, right? Okay, I think it's clear too, right? I will jump to here. So why we require to detect all these things is we need to detect the cancerous affected area. So developed areas need that, and only 25% areas, 20% of person. 1 second, I'll take some water. Okay. 22% of the patients are correctly detected, so that they are surviving actually. So that early detection will help us to, I mean, in the survival up to 70%. That's the reason behind that. And why I have mentioned is that CT is a very imaging modality, good imaging modality used to detect lung nodules. Actually, I think it's clear to you, right? So I think the main challenge is very important actually. The main challenge of the detection of lung cancer is that the presence will be of different sizes. It will be different intensities. So it will be a different size, different shapes. So that is very challenging. You have already seen the picture that it is appearing on different parts of that lung, right? So that soft tissue is almost similar to the normal tissues, right? It is very difficult to identify that kind of nodules. Nodule is very severe, right? So that is very challenging. So the first one, let it be. So I will wind up the session by 9 o'clock. What I couldn't cover today, I will continue for tomorrow, right? So if you are interested, okay, if you are interested in my session, please continue tomorrow also, right? So first technique, I think I am running very fast. First technique, shall I take a breath and is that okay? Can you follow me? I think I'm not boring you. Is that okay for you? Can you follow me? How is the session? Can I continue like this? Yes or no? Is that okay? Right, right. So I think we have only 10 minutes only. So yes, right, right. Okay. I think it's. I think you are hearing some good contents from here also, right? You are getting informative as well. Okay, I'm reading the chats as well. Okay, fine, fine. Okay. So let it be here and see. See, normally when I'm taking the sessions of machine learning and deep learning, I will be having some wonderful, good stories. I will be cooking some good stories and clearly explain you. But today, medical imaging is all about some technical terms only, right? So that's why might be you are getting boring, right? Let it be okay. So detection and localization. Here you can see that this is one of the work we have done actually. Lunar dataset is a dataset we have used. Lunar dataset. I think you could have some pipeline or framework like this. Okay, Lunar dataset. See, this Lunar dataset is actually see what how I could explain is that I think I have added the data. See, Lunar dataset actually this is a database LADC IDR dataset and it contains 888 CT scan images. Okay, 888 CT scans, right? So you can see that this is the data set what we are having. And from that, we are taking some ROEs. We are taking some ROEs, region of interest. Region of interest means the name itself, region of interest. Region of interest. Interest means where it is located. And that region you should extract. Hope you got that, right? Region of interest might be that, for example, we have the entire image. So some areas we need to extract, I mean, crop it properly. Okay. So that area only need to taken care for the classification. I mean, the rest of them can be, I mean, no need to take it. That areas only need to be taken, right? So that is ROE, region of interest, right? See, that we can call it as patch size. For example, we have an image of 220 into 220. So that patch I could extract. I mean, for 14, for example, I have a size of 40 into 40. I could take that. See, I have that. I can extract that area 40 into 40. So that is the patch size what we are. So that is all about ROE extraction. My dear audience, I think it's clear what is ROE extraction, right? So, for example, I can try here. For example, I have an image. Let it be 1,000 images, and I am extracting a 40 by 40 from here, 40 by 40 from here, and for example, such 40 by 40 images. How many images are there? 1,000 images are there, right? It will be 1,000 images. So that data set, I think the faculties know about training and testing, right? That 80% of that images, I can take it for training. So I am in a belief that you know the concept of training and testing, right? And the remaining 20%, we can take it for checking, right? I think, hope you got, can you chat me? Hope you know training and validation. Can you chat me? Yes, right. I think you, so my part is over. My job is, I mean, it will be help me. So 80% is taken for training and 20% for validation, right? So, and how we could do is that train the data or data model, I mean, data set using a RustNet. Okay. What do you mean by RustNet? Can anyone tell me what is RustNet? RustNet. Can anyone chat me RustNet? I think around 100 participants, 119 participants. Can anyone tell me RustNet? RustNet. So have you heard about CNN? CNN. Can you tell me CNN? Convolutional neural network. Okay. Convolutional neural networks are of different types. Okay. RustNet is there. ImageNet is there, VGGNet is there, AICTE-ATAL is there. I hope you heard that, right? So that we can use it for classification actually. So that patches will, that areas we can extract it for the resonant model. And so we train the model that, yeah, these are all the affected areas you need to take care of. So once you have the training, the remaining process is called a testing, right? So when I'm giving a new image, so that 40 by 40 area is taken, that 40 by 40 area is taken, and I am giving into the ResNet model what I have already trained, right? So that it will identify the the presence of the presence of the object where it is located, right? So that is all about the work what we have done initially. So hope you got an idea that, right? Lunar dataset, RO extraction. So this is the architecture of ResNet what we have used, right? So again, I will tell that the Lunar dataset contains of 88 CT scans. So from that we have extracted ROEs. So from that ROEs, for example, we have 88. So that 88 ROEs. Now we have ROEs only. So that we have taken 80 for training and 20 for validation. So how we can use that? That 80% is taken for training. So what we have used for training is that the CNN architecture called a ResNet, right? So ResNet is actually ResNet. So I'm not going to the workshop of CNN. That's why I'm not explaining now. Hope you got that, right? So if you are aware with the CNN, that image ROE, we are feeding into ResNet so that at the end, the dense layer, the classification layer will, so two neurons will be adding at the end. So one will tell that whether it is nodule affected, and it is non-nodule. Affected or not affected. So that's the end of ResNet there. And how the extracted ROEs is look like this one, right? Finally we are using that. See the Lunar dataset. We are extracting the ROEs, and the ROEs will be looking this way, right? Sometimes the images will be appearing in different formats, right? So this will be in different ways, right? So this we can say that. So so this one part I have done. So we have done that. So dear participants, is that idea clear to you? So this is a framework. This is just a framework I am presenting before. Okay. This one framework I have presented before. Okay. Is that clear to you? So you can go in this way. For example, if you have an image dataset, you could extract the ROE of that image and you can use it for classification, and you can give a new image for testing. So just I will go through the another one as well. Classification of nodules, what we have done is like another dataset. There is another dataset in lung cancer is that AICTE-ATAL NCCD dataset, right? So in that dataset, actually, 1, 5, 3, 4 images were there, and out of that, 3 classes, 430 are benign, and 516 are malignant, and the remaining 588 were normal, right? And training, like the training set, we are having the testing set as well. 660 images where these 64 images in the folder were benign, malignant, normal, right? So when 3 classes, benign, malignant, and normal, right? So what we have done is like we have trained it for 80 epochs, and it is having a learning rate of 0.001, and I think, dear participants, you know about what is epoch, what is learning rate, and what is optimizer, right? Can you chat me? I think it's clear too, right? I think it's very clear too, right? Dear participants, clear too, right? Right. Okay. I think you know the concepts, right? So anyway, I have mentioned about the classification part. So I think just I need to move to the radiomic features. Okay. Then I will how extract the feature extraction. So these are all the techniques actually I need to do. I explain to you. So I think I can explain the radiomic features also, because only 5 minutes are left for me. So 2 works I have shown you. Another work we have done is using the radiomic features. Using the radiomic features means different kind of features we can extract. Okay, different kind of features in the sense first order features are there, morphological features are there, and textual features are there, right? So different kind of features are there. So quickly I will go through what is first order features. So first order features means they chose the, have you heard about voxel intensities? The pixel intensity. The first order features works with the intensity based features. Okay. Sometime used on the voxel intensities, we could plot a histogram. Using the histogram, we can take the mean of histogram. Okay. We can take the one second, mean of the histogram. You can take mean is all about to take the average intensity of the histogram. Skewness means the asymmetry of the distribution we can find out skewness, and sometimes the entropy, the randomness of that distribution. Energy means, I think, the squared in sum of the squared intensities. So by drawing a histogram, we can calculate the sum of the intensity like energy, the randomness of the intensity like entropy. All these features we could extract. So that's all related with the first order features. And another thing, the morphological features. So morphological features means it is based on the shape. So it is a shape-based feature. So shape-based features in the sense, actually, what I could say that surface area. Surface area means the area that cover the lesion boundary. I mean the affected area boundary. That surface area we could identify, right? And voxel volume. Voxel volume means the size of the lesion. I mean the size of the lesion. How much centimeter actually? How much millimeter? Okay. And elongation means elongation is actually, it's a kind of a ratio. Okay, a ratio to the, so when we are plotting that, for example, the ratio of the longest axis, that is y-axis, right? The shortest axis here is x-axis, right? I mean shortest area. The ratio of the y-axis to the x-axis, that is elongation. Okay, so sphericity means how, what I could say that how close the shape to a perfect sphere. Sometimes it is not like a sphere, it is like an amoeba shape, right? So that we could measure using sphericity. So let it be there. And the another kind of features is the textual features, right? Textual features is the second features. You may note it down. GLCM is gray level co-occurrence matrix. GLRLM means gray level run length matrix. GLM SCZM means gray level, I think it's size zone matrix. NGTDM means neighborhood gray tone difference matrix, and GLDM is gray level difference matrix. So I am not going to explain in detail. These kind of features we could extract. So utilizing the ready-made features, we could try it for classification. So what we have done is like a wavelet transform we have performed. So there, once we perform the wavelet transform on image, since we have a 3D image, so 8 sub images we could. I mean 2 for 3. If it is a 2D image, it will be 2 for 2. I mean 4 kind of sub images we could take. So LLL, LLH. So I will show you. Like LL means low in all 3 directions, it will give the smoothest volume. LLH means detail LL. So I'm not getting into detail because I'm not a doctor. I mean academically doctor, not a medical doctor. Okay. So anyway, we have extracted all these features, and so how we have extracted is that once we had the CT images, we have extracted the ROE, and using that wavelet features extraction, we have extracted the various ready-made features, and that features we have fit into a classifier, where classifier has classified and into. So how we have done that feature? I mean, a lot of features we have extracted, and using, but how we can done is that, so based on the classifiers, we have arranged the features. I mean, we have arranged the features using extracted as well, and the top features have been taken and given for classifier for the classification, right? So I think I know that the last 50 minutes I'm boring you, right? Okay, anyway, I need to display all these technical details. Anyway, I think I should wind up here because I want to get into a special or a fresh topic tomorrow. Right, I think, is it okay to? So tomorrow we have seen, and today we have seen an introduction part for AI in medical imaging. Then we have seen the lung cancer part. So various kind of modalities like based on intensity, based on location, based on histopathological subtype, based on TNM staging, based on T, based on N, based on M, and based on the T and M together, we can see the classes. And first work we have seen using a LUNA dataset on a resonant model. Second one we have seen a AICTE-ATAL NCCD. I think these are all datasets familiar, new to you, right? It's not familiar to, right? So far, right? So this I have shown another dataset. The third one I have shown that by extracting the ready-made features as well, we could do this, right? So this one I have shown you. So tomorrow I will continue with the remaining part, and I will jump to the another continuing session and the retinal part as well. So shall I wind up now? Is that okay for you? Can I wind up? Is that clear? So I would like to know the feedback. You please send the feedback to your organizers. Is that okay for you? Hope you're beneficial for this. Is that clear to you? Can you tell me? I think it's not boring, right? I am continuously talking with you, right? Yes. If it is a live session, I will be watching you, right? Okay. So the participants, can I stop now? Right. I'm reading a chat. Okay. So, Vidya ma'am, shall I stop now?
Yes,
Right.
sir.
Anyone? Yes. Okay. Okay.
Yes, sir. We sincerely thank Dr. Sumod Sundar for delivering an enlightening session on diabetic retinopathy classification using deep learning techniques as part of the faculty development program organized by the Department of Computer Science, KMEA Engineering College. The session gave the participants a clear understanding of how deep learning methods can be applied in the early detection and classification of diabetic retinopathy, showing the importance of artificial intelligence in healthcare. Dr. Sumod Sundar's expertise and practical insights made the topic easy to follow and highly informative. Your presentation made even complex topic very easy to understand. And sir, now we understand why you were honored with the Best Faculty Award. We are so humble and grateful for your valuable time and effort in sharing the knowledge with us. It is our blessing to get such a good resource person like you, sir. Thank you so much.
Yes. Thank you, organizers. Thank you, KMA College. And thank you, dear participants, for hearing me for the last 1.5 hours. So thank you, everyone. Good night. See you tomorrow. Thank you.
Now, may I request all the participants to kindly turn on your cameras for taking the photographs? Thank you. Thank you all. Dear participants, so tomorrow is the final day of our FDP. There will be 3 sessions, a feedback session, validation, as well as a test session. It starts from 2 p.m. The online test as well as the feedback session will be from 6:30 p.m. to 7:30 p.m. So see you all tomorrow. Thank you.
Thank you, Namita.